All right, guys, hopefully this doesn't get to you too late, at least those of you taking on Tuesday and Thursday. So in order to kind of go through this kind of quicker, I'm going to use the semester exam review that's already a key and just kind of go through some things. So let's get going. Number one, vertical angles, right? It's just simply angles that are across from each other. I don't think y was intended to be an angle here. I assumed it was a point. So the main ones you would name are 2 and 3. But 5 in whatever this angle is will be vertical. And don't forget that they're congruent. Whatever they are, they'll be equal to each other. 2, don't overthink this one. Every teacher at John Jay is female. That's a statement. Provide a counterexample. Counterexamples simply say, this statement is not true 100% of the time. Here's one reason why. It can be proved wrong 3,000 times or one time, doesn't matter. So this would be like saying, if you are a teacher at John Jay, comma, then you are female. So the idea to a counterexample is that you do want to keep the first part right, but not female. So I am a teacher. Mr. Rodriguez is a teacher at John Jay. That's true. But I'm not female, I'm male. Literally, you can name any male teacher at John Jay as a counterexample. It's just one example where this statement is not 100% true. Number 3, the midpoint of AB is M. The coordinates of M are 1, 4, and the coordinates of B are 5, 1. So what you see here is the way to put it into an equation. Basically, you do the midpoint formula, but instead of finding the midpoint, which usually finds you the x and y of M, the midpoint, you're missing one of the 2 points, so you do that. First step is to multiply by 2. What we usually do, we do the line, right? So M is in the middle. There's not a lot of space to write here, but I'll kind of go like from here. So from 1 to 5, that is plus 4. But if you're going to go to A, the other coordinate, you're going to have to go minus 4. Right? And 1 minus 4 is negative 3. So that's the x of A. And then for the y's, from 4 to 1, that's minus 3. So in the other direction, it's plus 3. 4 plus 3 is 7. Negative 3, 7. That shows you how to do it algebraically. Are these lines parallel or perpendicular? You need to solve them to y equals mx plus b. So 2 steps. 1, subtract the x from both sides. So this had minus 9x first. This had minus 7x first. And then the second step, divide by the negative 7. So positive 9 over 7, because negative divided by negative. Negative 7 over 9, those are perpendicular. Write an equation perpendicular to the line. So AB, if you look on your paper, has a slope of down 1 over 4. That's this slope. But if you're going to be perpendicular, you have to do the opposite reciprocal. So you flip that, change the sign to positive, that's this slope. To write an equation, you need 2 things. Let me change the color. You need a slope, you need a point. Then what you'll have on a formula chart, you plug it into point slope form, and that's y minus y1, right? y1 from the point. Equals slope times x minus x1, and that's x1. All right, that's pen's not working very well. I'm kind of clogging it up already. But yeah, so you just need to know if it's parallel or perpendicular. Parallel, of course, the same slope, perpendicular, opposite reciprocal, and you need the point, you need the slope, and you plug those 2 things into here. Okay. 6 was a simple definition, a line that is perpendicular and contains a segment's midpoint. right? Perpendicular bisector. Perpendicular, literally there. When you go through the segment midpoint, you cut it in half. That's why it's bisector. So, name 4 pairs. There's tons of answers. These answers all work. So I'll just kind of explain why each one does. Supplementary, of course, means equals 180. You can have angles right next to each other like this, because those are always supplementary, or either of your same side, right? Same side exterior, same side interior. Those are going to be supplementary along with linear pairs. Congruent obviously means the same. That's going to be your corresponding. 1 and 9. Those that are in the same position, that's going to be either of your alternates. Alternate interior, alternate exterior, and your vertical angles, right? And then corresponding are congruent, but they're a specific type, so it's only those ones in the same position. So that's why you have 2 and 4, 9 and 11, 3 and 11, right? So you just need to know the definitions of those corresponding, supplementary, right? In the figure, J is parallel to K. Solve for X and find the value. In this problem, 5x minus 20, 3x plus 40, those are same side exterior. That makes them supplementary. So you see the equation, you add them up, set it equal to 180. You solve for x. So there's your x value. And then you plug the 20 into each one. The top angle equals 80. The bottom one equals 100. Okay. Number 9, if 2 angles in a triangle have measures of 58 and 70, what must the supplement of the third angle be? So you add them up, you get 129. I grabbed the pen that doesn't work well, of course, but that's how it works. If you subtract that, you get 51. That's the third angle. But the supplement is what makes it equal to 180. It's this angle out here. What's 180 minus 51? Takes you right back to 129. So read questions carefully, guys. Knowing the vocabulary, you know, it's multiple choice. It'll be help, but there'll also be trick answers in there. List the angles from smallest to largest. So shortest side, smallest angle. Middle side, middle angle. Longest side, largest angle. That's what the order's from. Opposites, big across from big, small across from small. All right, that's page 1. We're going to move on to page 2. Keep going. Whoa. All right, that's fun. Give me a second to fix that. All right. Which of the following segments can create a triangle? Add the 2 small numbers. They have to be bigger than the third. 3 and 5 is equal to 8. Not greater than. So that doesn't work. B, 5 and 8 is 12. That's bigger than 10. And she's actually showing you here all the different combinations of it working. But remember, all you really need to show are the smallest 2, because if you include the bigger side, it's always going to be bigger. And then 6 plus 10 is 16, not greater than 20. So the only one that works is B. What classification? So it's very important you differentiate between problems like 11 and 12 when you're given 3 numbers. Which of the following can create a triangle, and how would you classify with these side links? So if you're just trying to see if it is a triangle, it's A plus B bigger than C. If you're classifying and you assume it's already a triangle, that's Pythagorean theorem, or the setup for it, a squared plus b squared equals c squared. So 5 squared plus 12 squared is 169. 13 is 169. If they're equal to each other, it's a right triangle. If they're not equal, a squared plus b squared bigger than c squared, that's acute. And if it's a squared plus b squared less than c squared, that's obtuse. All right, 13, QRS is 94, so the whole angle is 94. Find QRT, which is right there. So obviously, it's simply 94 minus 34. And there you go. Are the lines parallel? Justify your answer. Okay, so this is hard to see on my copy, but what do we have here? Okay. I actually had to pause that real quick to check because this copy when it's scanned, but you have curves right here, and so that's why the answer is what it is. So just so you remember, all those angles we know, alternate interior, alternate exterior, if you start with the assumption that the angles are that the lines are parallel, then all those angles exist. If you don't know the lines are parallel, but you can show those exist, then it proves they're parallel. Right? That's what's going on there. Number 15, are they parallel? Yes. You see the markings, all three sides matching. Remember, okay, so we just did similarity a little while ago, and that had shortcuts. But this is congruence. Those shortcuts are SSS, SAS, ASA, AAS, and HL. Those are all congruents. There's 5. Okay? When we talk about similarity later, there's only 3. Congruence, they are exactly the same. These all 5 work. Okay? And then 16, speaking of congruence, which 2 do not work? AAA and SSA. Right? So those are the 2 that do not work. AAA, because we saw that with similarity. They can have all the exact same angles, but can be to completely different sizes. SSA, it's just that it's not a lot of different possibilities, but there can be 2 possibilities that match SSA, but still are not exactly the same. But just remember, ASS and then AAA. On the figure below, what is the value of x? So this is an exterior angle problem. This exterior angle x equals these 2 added together. That's where they get the 120. Because these are vertical angle, 40 right there. Y is the 2 over here added together. That's where they get 110. The question is, what is the value of x plus y? And they just add them together. Okay, that's exterior angle being used there. A couple things on this problem. So honestly, neither of this is really pertinent to the problem. The intention was to cover that 13. I think when we copied the picture, we forgot to bring the little text box we covered it with. And this was just extraneous information. It doesn't affect the problem anyway. AD is 30. G is the centroid. Centroids cut lines, remember, into 2/3, 1/3 divisions. Okay, so A to G is 2/3 of the line. D is G to D is 1/3. So what she did here is she divided it by 3, right? You get 10. When you divide it by 3, that's like multiplying by 1/3. So that, what she did right here, that's a highlighter. What she did right here is going to give you that part. So from there, obviously, you could do 30 minus 10 to get the 20. Also, if you want, because A to G is clearly the longer part, you could also do 2/3 times the value, which in this case is 30, which would give you the 20. Right? But it just cuts into 2/3, 1/3. The longer part should always be twice as big as the shorter, because 20 is twice as big as 10 here. Right? In the diagram number 19, DF is the mid-segment of the given triangle. Find the length of BC. So very simply, if this is a mid-segment, first of all, this is parallel to this line, and then more importantly, it's half. So this is simply 12 times 2. That's pretty straightforward. 20, again, like the problem previous, this is an exterior angle. 120 is equal to these two added together. So you'll see in the equation 3x plus 72 equals 120. Minus 72, you get 3x equals 48. Divide by 3, 16. Okay? So we're going to keep moving to page 3. All right, page 3. Again, these shadow problems. 6-foot man casts a 10-foot shadow. The tree next to the man casts a 30-foot shadow. Those create similar right triangles, so you can see they did 6 to 10 equals x to 30, cross multiply. You can also do 6 over x equals 10 over 30. It works both ways. The math works out the same either way. 22, write the inverse, converse, contrapositive, and biconditional. Might want to check your foldable for this. If I study, I'll pass the test. Inverse is not original order, but not. So if I don't study, I will pass the test. So original order, but they negate the original two statements. If I do not study, I will not pass. Converse is a flip. Hypothesis to the back, conclusion to the front. So what was, then I will pass the test. Now it starts. If I pass the test, comma, then I study. Contrapositive is both. Contrapositive is a flip and a negation. I'm trying to draw flip symbols and negation, but this pen just isn't working very well. But contrapositive do both. If I do not, or if I will not pass the test, then I do not study. Biconditional, no if then. It's original hypothesis, but kind of looking up here, you cross that out. Original conclusion, cross that out. In between those, you put if and only if. So if you notice, I study if and only if I did pass the test, or I passed the test. Okay? So those should be in the foldables, or, I mean, again, it's not hard. Inverse is negation. This is a flip. This is both. And this is, whoa, what was that? And this is hypothesis, if and only if, conclusion. You get the idea. And that doesn't move. That's fun. All right, 22. If AB is the angle bisector of DAC and BAC is 52, then what is DAC? Whoa, what did she do here? Yeah, I think she read something wrong or was looking at a different problem because that's incorrect. Angle bisector cuts an angle in half. So if BAC is 52, then this is 52 up here. And you just add them up, you just double it. So it should be 104 because it got cut in half. 23, determine the length of GH and HK. Okay, so this is a geometric mean. Where's the A? Is that the A right there? The copy I'm looking at is kind of difficult. Oh, okay. So you can kind of put it however you want. So they only give you the 32 and the 8. So you can find this side first, and that's what the B is. All right? So the B is going to be the geometric mean between the 8, the small side of the hypotenuse, and the big whole hypotenuse, like that. So you multiply them, you get 256. You square root that, they get the 16. And then the A, which should be for this side, is the opposite. So A is the geometric mean between 24, and the way you get 34 is just real simple, don't overthink it. The whole thing is 32. You know G to that point is 8, right? You know this is 8. So 32 minus 8 is 24. You set that equal to 32 over A, and I know you can't read that. Let me scoot it over a bit. So again, A is a geometric mean between 24 and the whole hypotenuse 32. So you cross multiply 24 times 32 is 768. You square root that, it doesn't come to a whole number. So, there you go. Here, so we haven't really done a problem like this, but guys, you got to be able to problem solve a little bit. You want to find x. If you draw a line straight down here, you get a right triangle. Now, since this top part is 5, that makes this 5, and then since this is 10, that's where this 5 comes from. This is a rectangle, so 6 and 6, and then it's Pythagorean theorem. 5 squared plus 6 squared, they reversed it, but it doesn't matter. Add them up, square root is 61. All right, on to the page. Whoa. All right, how are the two triangles similar? Again, it's really hard for me to see the markings on the copy, but I think it's something like this. Actually, let me take that back for a second. It's probably more like this because this is similar, not congruent. So again, you got to be careful. So all three of these are the same. They're equilateral. These are equilateral. The similarity by side, it doesn't matter what numbers I put here, right? These are all the same. These are all the same. They're going to create the same fraction 3 times, all right? If I call this 2 and I call this 5, all the sides make 2 over 5, 2 over 5, 2 over 5, right? And remember, to be similar, you have to have all 3 sides, or one way is to have all 3 sides give you the same fraction. So no matter what numbers, because the smaller ones are all the same, the bigger ones are all the same, it's going to be the same fraction no matter what number you put there. B are not similar, and in the first one you have 92 and 57, and the second one you have 92 and 41. So if you find the third side for each triangle, thinking that the one that's missing is the one that matches in the other one, it doesn't. So don't always assume similarity. If all 3 angles don't match, they're definitely not similar. And then you look at this one, and it has 2 angles. This time they do match, the 2 they give you. So you could do that. Honestly, you could probably do SAS too, because 6 over 4, like if I go 6 over 4, that's 3 halves. And then if I do 10.5 over 7, that reduces to 3 halves. So I could do SAS. So either one works. And actually probably side, right? So it looks like all 3 are possible there. It's just explaining it, or multiple choice. It's whatever answer best fits. Use the following picture to answer the questions. Name the point where AB intersects CD. Don't overthink that. Literally, where are they crossing, right? Sometimes some of you guys think this has to be way harder than it does. Name 2 sets of 3 collinear points. AEB, right? In a straight line, collinear. And CED. That's it. Are points A, E, and D collinear? No. Sorry. Okay, so pretty clear. I hope that helped a bit. Again, you'll have a formula chart, and we'll make things work. We'll be good. All right, good luck.